Welcome to a Metro Siege Amiga update. Recently I've been doing a lot of work on the debugger, but the sole reason for this debugger to exist is really so I can use it for Metro Siege development. So today I'm going to just quickly go over a couple of little optimizations I've made in preparation for us starting work on Metro Siege post Kickstarter. And after that, I'll quickly run through a little experiment I did about how we can make, what it would take to make Metro Siege run at 50 frames per second. So stay tuned for that. So the first thing I'm going to do is just show you, there's three different ways really in this debugger that I use to get profiling information. The first one is what I call these profiler checkpoints. So basically when the game's running, I can enable this checkpoint profiling, and what we'll see is that at different points through the main loop, the program just writes a number, and the debugger then keeps track of cycles and scan lines for each of these different parts of the main loop. We can put a overlay renderer on this, which is kind of similar to the old copper bars technique that people use to do the same thing. And what we can see here is that, on Amiga 500 with 2 players and multiple characters and other items on the screen, that we easily blow past a full frame, and mainly in DMA stat and DMA usage, DMA slots. So we can see here that just the rendering of objects alone is taking a significant portion of a frame. If we add into that the object clear, rendering of shadows, we're not really having much time left. So this is basically in a nutshell at the moment why Metro Siege runs at 50 FPS, but that doesn't mean we still can't make optimizations, even with a 25 FPS baseline. So, one of the big things we do is constantly struggle for RAM. So I did some optimizations on RAM usage to try and buy myself a little bit of extra, what I'll normally call fast RAM, but really what I mean is not chip RAM. And when we run an automated test like this, another thing that Metro Siege does is it collects a whole bunch of stats about the number of CPU cycles that have been used to render each frame, what the memory usage, low and low watermarks are, and that sort of thing. So the results would look something like this. We have the number of skips. So a skip is when Metro Siege isn't able to render the frame within the target FPS. So in the case of 25 FPS, this would mean that it would take 3 frames to render. So for this baseline test, we had no skips on level 1. This is the total number of CPU cycles. It's not the exact number of cycles. I think it's maybe cycles divided by 4. I can't remember what I did. Just to make that size more manageable and less likely to overflow in a 32-bit variable. So this was the baseline. We can see that this is basically the number I was mainly trying to optimize, which is only 9K of free non-chip RAM. And post-optimization, we can see that the main goal has been achieved. We've bought ourselves not quite 20K extra, but a significant amount of extra fast RAM. Now, the problem with this was that the changes I made to actually do this made the game slower. So then my goal was to then optimize it back to at least the same spot, if not a little bit better. So what I then did was use not so much this profiler, but the main profiler. Now this is profiling every instruction and mapping it back to C and assembler source lines. And from this we can get a detailed look at where all the time's being spent. This is what the profile output looks like. Now, I'm not going to go into this in detail other than to say that, this first line is just waiting for the 25 FPS thing, so it's waiting for the vertical blank interrupt before it progresses onto the next frame. But what we can see here in this sort of very simple flame graph is that most of the time spent rendering the object, clearing the object, rendering shadows and whatnot, and that's sort of basically what the profiler gives you. You can dig into the source lines. You can see here, after my optimization, I basically rewrote the main object rendering loop as inline assembler, but unfortunately this profiling system that I've got collapses that into a single C statement. So that's maybe something I need to work on in the debugger profile. So what does this mean? Well, yeah, we can see that the total number of CPU cycles in the post-optimized version is less than the total beforehand. Not by much, less than 1%, but there we go. Level 2, similar thing, reduced fast RAM usage, and in this case, a slightly better, level 2, a slightly better result where it's a little over 1% faster. So that's good. But still nowhere near enough to make it run at 50 FPS. We're talking small amounts of improvement here, tiny amounts, mainly focused on buying extra fast RAM so that we can add new features to the game as we progress the development. So what about this 50 FPS thing I've been talking about? Well, if we look at this, we can see that the majority of time is taking up with blitzing. But another thing that takes a lot of time, if we look at the DMA stats, is the bitplane DMA. So in Amiga world, we've got OCS and ACS Amigas that have a bitplane fetch size of 16 pixels, and I did wonder what would happen if we just, for argument's sake, use the AGA fmode 2 to try and reduce this. So let's run another version. This time we're going to be picking a Amiga 1200 config with some fast RAM, but the CPU at the default speed. Just see what would happen. Well, I guess if we've got a slightly faster CPU, if we've got fast RAM, and if we've got a different F mode, what will this mean? So I'll run the game again, and we'll look at the DMA stats now, and we can see immediately the bitplane usage is pretty much halved. And what that means is not only is there more decent DMA slots available for that, it means that the blit is essentially quicker, because I think the DMA slots that were used by the bitplane DMA can be also used by the blitter. So what we end up is the blitz are a lot quicker, and with the faster CPU and running out of fast RAM, the CPU cycles setting up these blitz are much improved. So this version is actually running at 50 FPS. I can put a little debug output here, and this is the game, what the game thinks it's running at. So it is 50 FPS. If it doesn't finish rendering in time between vertical planks, this will knock back to 25. And on a Amiga 1200 without any speed increase, and we have a lot of action on screen, this will actually drop back occasionally to 25. Luckily, you won't really notice too much in the game, because the speed of movement and the speed of animations is all tied essentially to the wall clock rather than to the frame rate. So when it drops to 25 FPS, the movements and animation speeds should say at the correct speed. So yeah, that's an improvement we get just by using the fmode 2. Now we can see, if I look at the chipset log, you can see here that I actually use two different F-modes at the moment. There's F-mode 4, I mean the value's 3 there, but it's really F-mode 4, I think, as per the doco. And that's actually 64-bit, or I think it's 32-bit with a double cassette, I'm not exactly sure, but basically I think it's even twice as fast again as F-mode 2. So that's used for the HUD. Why can't we use it for the main screen? Well, when you're setting up F-mode, unfortunately it's not just a simple matter of setting this register and getting free speed. You've got to change the way that you set up your bitplane fetch parameters in the chipset, and fmode 4 or value 3 means that the start of the fetch is way early on in the scan line, and that basically makes almost all of the sprites unusable. So for the time being, I've stuck with fmode 2 32-bit for the playable area where we have sprites, and I've gone for the slightly faster fmode 4 up there for the HUD. So what about a full AGA version? Well, not for the first release, that's for sure. When we do a proper AGA version of Metro Siege, it will use all of the AGA features. It won't just use the fmode version, the improved fmode, it will use, well, we'll see. But we're not going to have the capacity to redo all of the graphics and redo the engine to take full advantage of AGA. So in the first release, there'll probably be, you'll be able to select whether or not you want it to operate in this 50 FPS mode, and that could be useful. That could be useful, if you've got an accelerated Amiga, or if you're running an emulator and you want to run it at 50 FPS. But we're not going to have a full AGA version for the first release, almost certainly. So yeah, there we have it. A couple of little features of the debugger, some profiling stuff. Oh, the other thing, the last point I'll add is that we have actually had another optimization, which is in floppy loading. We can see here, this is basically the number of frames it took in the baseline to load splash screens, the menus, the character select, and the game before you're ready to play. And previously it was 56 seconds. And after doing some analysis and optimizations, that's gone down to 48 seconds. So we've got, about an 8-second improvement on loading so far. And that was not so much around changing the way that the data was loaded from floppies, but more about the way that it was processed after. So the debugger profile was really helpful there to give me some insights into where I had a bit of sloppy code that was doing a bunch of loops over stuff that didn't need to be done. So good news there for floppy users, and these times are based on a standard slowest, I think 300 RPM floppy. So if you've got a faster floppy disk, your loading times will be quicker than this. But as I said, this is not the time it takes before you sort of see anything. This is the full load of the game and set up all the way through to playing, so it's not too bad. So yeah, there we have it. The Kickstarter is going to be launching this week with any luck, and we look forward to everyone supporting it. I'll put some links in the description regarding that, and I'll see you next time.